Zeno's paradox: why motion should be impossible but isn't. What if I told you motion is an illusion, that every step you've ever taken, every race, every throw, every blink, is logically impossible? Don't panic, you're still moving. Probably. But 2,500 years ago, a man named Zeno of Elea said otherwise. And his logic was so tight that even modern physics still twitches when his name comes up. Welcome to Zeno's paradox, where running a race makes no sense, and even an arrow can't reach its target. Zeno of Elea lived around 450 BCE, student of the philosopher Parmenides, who believed that change and motion were illusions. Zeno's job? Prove it. And boy, did he over-deliver. He created more than 40 paradoxes, each designed to break your brain and defend his teacher's idea that reality is one unchanging whole. His most famous ones, the dichotomy, Achilles and the tortoise, the arrow and the stadium, are still discussed today. Together they form philosophy's first viral thought experiment: why you can't actually move. Imagine you want to walk across a room. Simple, right? Not so fast, literally. Before you can reach the wall, you must travel halfway, then half of that half, then half again. Every distance can be divided infinitely, meaning there's an infinite number of points between you and the wall. And if it takes time to cross each point, even an instant, you'll never finish, because infinity never ends. According to Zeno, motion can't start, because there are infinitely many tasks to complete first. Next up, the most famous, Achilles and the tortoise. Achilles, the fastest man alive, challenges a tortoise to a race. Out of pity, he gives the tortoise a head start. Zeno says Achilles will never catch up, because by the time Achilles reaches the tortoise's starting point, the tortoise has moved a bit farther. When Achilles reaches that new point, the tortoise has moved again. No matter how small the gap gets, the tortoise is always a tiny bit ahead. Therefore, the faster Achilles runs, the less he wins. It's math trolling before math even existed. Okay, let's shoot something. Scientifically, Zeno's arrow paradox says that if time is made of individual instants, then in each instant the arrow is motionless, frozen at a single position. If every instant is motionless, and time is just a collection of instants, then motion never happens. The arrow never moves. It's just an infinite slideshow of still pictures. Basically, Zeno invented frame-by-frame analysis before film existed. In the stadium, Zeno describes 3 rows of objects passing each other at equal speeds. Depending on how you count frames of time, their relative motion seems twice as fast and half as slow at the same time. It's Zeno's way of saying, you think you understand motion. Think again. Modern physics eventually solved this one, but only after inventing relativity and calculus 2 millennia later. Zeno wasn't trolling for likes. He wanted to defend Parmenides, who believed reality is continuous and unchanging. Motion and change, they said, are illusions created by human perception. Zeno's paradoxes exposed contradictions in how we think about space, time, and infinity. They forced philosophers to admit intuition isn't enough, we needed better math. Enter the 17th century, Newton and Leibniz roll up their sleeves and invent calculus. Calculus shows that an infinite number of steps can sum to a finite distance. For example, 1 or 2, plus 1 or 4, plus 1 or more say, plus 1. Infinity isn't a wall, it's just a limit. So Achilles does catch the tortoise, we can cross the room, the arrow does move, because the infinite series of tiny steps adds up to something finite. Take that, Zeno. Except, quantum physics later made it weird again. Here's where it gets wild. In quantum mechanics, there's actually something called the quantum Zeno effect, where observing a system repeatedly can literally freeze its state. So yes, under certain conditions, constant observation can stop motion from happening. Zeno accidentally predicted a real phenomenon 2,000 years early. Every time you check to see if something's changing, you might actually stop it from changing. He would have been insufferable on Twitter. Zeno's paradoxes aren't just about math, they're about the limits of human reasoning. They remind us that infinity and motion don't behave like our brains expect, that some ideas can be logically airtight and still utterly wrong about the world. But they also show that philosophy and science need each other. Without Zeno's mental gymnastics, we might never have invented calculus, relativity, or quantum theory. He was the ancient world's bug report for the human mind. Maybe Zeno's lesson goes beyond physics. Maybe it's about how we see progress. When you're chasing a goal, it often feels like you'll never get there, because you're focusing on the infinite tiny steps still ahead. But like Achilles, those steps add up. You just have to keep moving. Motion might be an illusion, but progress is real. So next time someone asks why you're late, tell them you were stuck in a Zeno paradox. And when you move again, remember, the ancient Greeks thought every step was impossible, until someone took it. This is 5-Minute Paradox, where we turn ancient confusion into modern understanding. One tiny, infinite step at a time.